Okay. So in diffraction, we did till here, and I told you about the formula. And what it means now. So this is basically the formula that's for Young's double slit, and now so suppose you have slits like these, okay? And wavelength like this. So from here to here, you would say this is my slit separation, and then when you see the slits, like when you see the screen, and on the screen you'll see like a maxima, and then another maxima, another maxima, like that, right? And then like between every maximum there is a minima, like that. And of course the first one is the zeroth, and then like I told you, it's the first, and then it's second, and similarly first on either side and second on either side, and then same goes for the minimas, right? So it's going to be first minima and then second minima. This is going to be first minima and then second minima. All of these, what you see right now, these are called the fringes, and between one fringe to another, like one maxima to another, that's the fringe spacing, or a minima to minima, that's also fringe spacing, same thing. And this distance from the slit to the screen, you have the distance too. Alright, is it clear everyone? Any questions that you guys might have? Okay. Now, so let's try and do a question. And from that we'll understand what basically we'll see. Just a second, please. Okay. Now suppose we have this question where they say that this is the diagram, and says why a bright fringe is produced at x. Okay, like that. So what you're going to do is, you know that this is double slit, as you can see from the diagram as well. And when you see a double slit, remember, like usually these type of questions come for 2 marks. So it is best to write that number 1, waves like overlap. You can alternatively write meet as well. It's a keyword, so I've put a star on it. Waves overlap at a point x with a phase difference, because we need to understand that phase difference will cause a big role in this, because phase difference, if it's 0 degrees, then it will constructively interfere. So hence constructive interference gives a bright fringe. Now if this was like the dark one, the minima, I would have said it's because the phase difference was 180 degrees or its multiples, because it was destructive interference. Okay, is that clear, everybody? Hamad, Aman, Aisha, Javeria. It's clear, right? Let me know if you have questions. Like, why bright fringe would be created? Because Aisha, when 2 waves or more just meet constructively, so they will create a bigger wave, right?
Yes.
Why dark fringe is created is because 2 waves meet destructively, which means they have 180 phase difference. So that's why it becomes dark, no wave at all. Is that clear?
Yes.
Currently it's talking about bright fringe, that's why I'm writing it this. Okay. Now, so now it says calculate D. The only formula that I have for double slit is AX equals to lambda D. Now A is 0.41, so I'm gonna change it to meters. X is, because now it's giving us bright to dark, so X must be from Y to Z, because it's either dark from dark or bright from bright. So X is going to be 4.0 times 10 raised to minus 3, because we want, distance from here till here, like that. Is that clear? Okay. So now the lambda is given as 580, nano is 10 raised to minus 9, and we want to find D. It's very simple, just put in the values, and what you should expect is, because we converted everything into meters, so you should expect 2.83 meters as the distance of the screen from the slits. Any questions here? Please let me know. Right. The intensity of light initially passing through the 2 slits was same. The intensity of light through one of the slit is now reduced. Compare the appearance of fringes before and after. Now, this question is a very important question, because now let's see what was happening before and what was happening after. So first of all, let's although we need to write about it, but I want to explain it using diagram as well. So it's not necessary to draw the diagrams if you don't want to. So first of all, we're going to talk about before. So before, what was happening, that if one wave was like this, right? Okay, let me make it a bigger one. If one wave was like this and another wave was like this, right? So both waves were like similar and similar amplitude because intensity is the same. So they would have given us basically a much larger wave that we know, like this, right? That's constructive interference. Because I'm just assuming that if the amplitude initially was A and the other one also had the amplitude A, now I'm getting like 2A. Alright, now think about it this way now. So in the destructive one, it would have been now afterwards one wave is the same as before, but other one is now has a smaller intensity, which means smaller amplitude. So when they meet, of course it's not going to give you as big wave as before, it's going to give you a bit smaller wave. So what we can say is, like, for example, if this is 2A, this is A and this is half A, so now it is going to give you like 3A, 1.5A, like it was giving you A before. So it's not going to be as bright, right? So we can say that now bright fringes will not be as bright as before, because the overall intensity, when you add them, it's gonna reduce. Now, so what happens to this was constructive interference. So what happens to destructive then? So suppose initially when we had the wave like this and the other wave, wait a second please. Okay, I made a mistake here. Suppose the first wave was like this and now the other wave is like exact opposite to it. When we meet, they're gonna completely cancel out. They're gonna cancel out everything. Okay, when they add you up, they're going to cancel out. So it will be completely dark. But now, because one wave, the first wave is the same, but the other wave is now smaller than before. It's not the same. Now because one is smaller, one is bigger, so the thing is that they will try to cancel out each other, but still some of it is going to be left. It's not going to completely cancel out. Okay, so we can say that the dark fringes will not be completely dark anymore, because some of the light still is there, it's not completely cancelled. So the third point is that this will reduce the contrast. When you say contrast, it means that it's going to reduce, it's going to, affect the fringes such a way that now, because darks are not completely dark and brights are not completely like really bright, so the difference between them is going to be less. So you can't see clear boundaries then, it will be mixed. Do you guys understand this? Yes, Aman, Aisha, Juveria, Hamad, any questions?
Yes, sir.
Okay, yes. Go ahead.
Sir, can you please explain the second part again about the dark fringes one?
Yes, yes. So initially, suppose this one had an amplitude of 2a, right? And because it was anti-phase, the amplitude here was minus 2a. So when you add the amplitude, it's going to give you 0, right? You agree?
Yes.
So it completely cancels out. But what if when it has an amplitude of 2a and this has an amplitude of minus a, it just does not cancel at all. So a will remain, right? So which means some wave will still be there. It will not be as bright as constructive interference has. It will not be as dark as, when it cancels everything. So it's not going to completely cancel, that's why. Do you get my point?
Yes, sir.
Yeah. What I believe in contrast is like you can clearly define colors. Like right now, if I say this is like completely dark, so you see a dark fringe, and then you see, let's suppose a red fringe. Now this has a pretty good contrast because you can see black and red, right? Now if
Yes.
it has like red, little bit red in it. Now this is not a good contrast because now dark is not completely dark and white is not completely, like the color is not completely red. Understood? Like that. So if it doesn't cancel everything, it means the contrast is going to decrease. Contrast is basically how identifiable two colors are. Do you get my point? How boundaries are?
Yes, sir.
You can write this down, please. Okay. Ahmad, how are you? Why aren't you speaking today? What happened?
Sir, good.
Okay. All right. You're getting everything right? Or no? Okay, very good. Now, so the next thing we're gonna do is, it is called the path difference. Now, by the just the word, right? You can actually understand that the path difference basically means that how long a wave has gone to a certain point, how much distance it has traveled, if you compare it to another wave, like that. It's called path difference. Like, say, for example, if I say, okay, I gotta go here at point A, so one person from S1 goes here, he only travels like 2 meters, and there's another person at S2, he goes to the same point, but now he has to travel 2.5 meters, so the path difference between these two will be 0.5. Do you get my point? Okay.
So it's just simple subtraction. No.
Yes, Ahmad?
I think is it just simple subtraction?
Yeah, it's simple subtraction, like that. It's very simple. Now, so when you define path difference is basically the difference in length between a point within the interference pattern from both the slits, first of all. Now, path difference is equal to n lambda. This is basically the main formula that you should remember. Now, there are other formulas. People will teach you different formulas, but it's alright. It's better to learn just one small formula, n lambda. I'm going to tell you what that is. So, what you guys need to remember is that for constructive interference, whenever they meet 0 degrees, right? So, constructive interference, just to remind you again, because I think Aisha has forgotten. Constructive interference, Aisha, is both sources are in phase, right? 0 degree phase difference. So then what you're going to do is you're going to take n as 0, 1, 2, and so on, like that. If at that point there is destructive interference means that they're going to cancel out each other or some part of it. Then that is only possible when both sources are anti-phase. Anti-phase means that they're completely against each other, so they're cancelling out. So n will be taken as 0.5, 1.5, 2.5, and so on, like that. So you got to remember that. Now, what to do? Let's see. I'm gonna post a picture. So if you see the diagram, it basically makes a diagram like this. So what I want you guys to remember is when these are like two slits creating that pattern, it's T, and of course some of the, like it's from another app, so some of their, this is A, that's T lambda, fine. So now, first of all, let's try to find out where the maximas will form, alright? So let me show you this. So if you go in the middle, right here, oh, by the way, I just wanted to tell you something very, very important. You see, when we make wavefronts, like you might have learned this in O-levels as well. Wavefronts are basically, like we've learned in like few chapters before as well. Wavefronts are basically the lines that connect, like the crests together. So for example, this is a crest, this is a crest, this is a crest, so it becomes a line. So every crest is connected at a straight line because this is the direction of the wave, just remember. So wavefronts are like, perpendicular lines that connect crests. So it means that the solid lines are all crests, and if I say you want to display troughs, you generally do it with a dotted line. So if you connect troughs together, they are basically dotted lines. So crest, trough, like this. So all crests are connected like this. Currently we have only crests shown in this, but I'm gonna draw a number of lines, so just to depict, right? So for the first one, I'm doing it with my hand, so it might be a little bit different. So for the first source, let's call this S2, let's call this S1. So S2 source, I'm just making the dotted line to show crests, troughs in the middle. So every solid line is a line which connects crests, and the dotted line is a line that connects troughs. there will be a little bit difference only because of my movement of my hand, like that. And then for the other one, let's use another color, pink would do. Okay, I'm trying my best. Like that, okay? So now what I want you guys to understand is that when, for a constructive interference, a crest and another crest meets with crest and troughs meet with troughs, so that causes a constructive interference, right? For destructive interference, it is when a crest meets with the trough and the trough meets with the crest, then it becomes a destructive interference. Is that clear, everyone? So if you look at like this point right here, you might see that the solid line is meeting solid line, which means it is constructive interference. Is it clear, everyone? Same goes for this point. Troughs are meeting troughs, crest, crest, trough and trough, crest and crest, and so on. So right, in the middle, and it will always be the same, unless, yeah. Right in the middle, we will see a maximum. Alright, is that clear? And that would be the 0th order one. It's very important. Similarly, if you look at this point, and 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 this point. So right here, a little bit different because of my hand. If you go in a straight line, this point is also going to be a maxima because all these points interfere constructively. And on the other side, it will be the same. So if you draw it, so here you would witness another maxima, and these maximas are basically the first order. Very simple. From the lines you can actually judge what's happening. Interestingly, if you look at, like, I don't know which color to choose. Okay, wait a second. Let's choose this one. So if you look at this point, a dotted line meets a solid line right here as well, right here as well, right here. So just in this line, basically all the points are destructively interfering, which means at this point you will witness a minima of the first order. And then if you see here, oh my god, if you see here, a dotted lines meet solid, dotted solid, dotted solid, and so on. Between troughs and crests are meeting. So right here you will also find a minima. And that's the first order as well. Alright? Okay, you guys understand up till now? Now, so why do we call these 0 and first and so on? Because interestingly, when we basically, like, the waves basically are generated from this point and this point. So if we go from S2 to the center one, we have to move this much distance, and from S1 to this we move this much distance. So basically both have the same length, So their path difference is basically equal to 0. And how can we know this? Because from the formula, n is 0, it's 0 times lambda, because n is 0, right? Like that. Is that clear? Now, if we go to the next one, like from S1 to the next maxima, and then from S2 to the next maxima, you might realize that basically the waves need to travel a longer distance from S2 to S1 to reach that point, which means now the path difference here is going to be equal to 1 lambda, because n is equal to 1. Do you guys understand this? It will also be the same as either side. It's basically because of n equals to lambda, like that. Okay, now for the minima one, when we calculate the path difference from minima is going to be 1.5 lambda, like 0.5, sorry, 0.5 lambda, because it's in the middle of 0, 1, and n is 0.5, and also on the other side it would be the same, because n is 0.5. If I say, okay, if there is another maxima after some time, right? Why do we call it the second order? Because now its path difference is going to be 2 lambda, which means here n will be 2. And if I say, okay, there is a minima in the middle, which is the second minima, so its path difference okay. So its path difference is going to be like 1.5 lambda, because n is 1.5. So for minimas, it goes like 0.5, 1.5, then 2.5, and so on. For maximas, it goes like 1, 2, 3, and so on. 0, 1, 2, 3, and so on. Is that clear? Ahmad, any questions here? Okay. Now I'll basically show you one question, and from that we're going to understand what exactly has happened. Okay. Now a question says that a source of microwave sends waves, the wave in two paths, A, B, C and AC, as you can see. If the wavelength of microwave is 2 centimeter, deduce whether at C a constructive or a destructive interference has happened. So what you're going to do is, so from A to C, the distance that the wave has moved is equal to 12 centimeter, right? From A, B, C, the distance it has taken is 4 plus 6, which is 10 centimeter. Do you agree? Now the path difference here is 12 minus 10, which is 2 centimeter, and path difference is equal to n lambda. So we can write 2 centimeter equals to n lambda, because the lambda was 2 as well. So 2 equals to n times 2. So n becomes 1. Since this is a whole number like 1, so this means that this is constructive interference, because in constructive interference the n is always 1, 2, 3 and so on. If this was like 0.5 or 1.5 or 2.5, we would say that it's destructive interference. Understood?
Why did you take lambda as 2?
Because they said the wavelength of microwave is 2. If this had been 0.5, 1.5, anything that is a multiple of 0.5, then we would say that okay, this is destructive interference. If it's a whole number like 0, 1, 2, 3, we say it's constructive interference. It is as simple as that. Understood?
Yeah.
Okay, you guys can copy this. So we're gonna stop here now for today, and inshallah we're gonna complete this. I think in this week our waves are going to finish, which is a good thing, and then we're only left with 2 chapters. So hopefully by the mid of December